Today we have two learning targets. One is that we're going to review how to solve one-step equations, and the next is that we're going to use our math notebooks and our digital portfolios to record our learning. You'll notice that I just wrote the word date here. This is the third page of my math notebook. I left the first two open in case I want to go back and put a table of contents. I'm not going to require you to use a table of contents, but let's leave a little bit of space in case you want to. So skip the first couple of pages, start on this first page. We're going to use our pages in consecutive order. That means one right after another, and we're going to use the front and the back of them because otherwise we will use up too much paper in the course of a year. I'm going to ask you anytime we start to take notes for you to start with the date. So you're going to fill in the actual date. Today happens to be August 26th, but I'm not going to fill it in always on my notes and on the video because I might make the video on Tuesday, plan for us to watch it on Thursday, and we actually watch it on Wednesday. So I'm going to leave the date as just the date. You put in today's date, then LT stands for learning target. You don't have to write that, that's up to you. But I do want you to write our two learning targets for this video. Again, we're reviewing one-step equations, which should be pretty straightforward for you. We're also using our math notebooks and our digital portfolios to record our learning. So I'm going to show you what that looks like. We are going to start with a few examples. The importance of the examples are that it reminds you how to do these problems, but also that it shows you what my expectations are in terms of how you're showing your work. So example number one, we're just going to do a very straightforward one-step equation. So I've got x minus 7 equals negative 6. And many of you like to draw a line down the middle. That line to me is optional, but it does help you keep your work organized, and a lot of teachers like to see that line. I'll tell you the things that are optional and things that aren't optional at the end. I know that when I'm solving a one-step equation, I want to undo all of the operations. So if I'm currently, and my goal is to isolate x. So if currently I'm subtracting 7 from x, I'm going to choose the opposite operation and add 7. And when I add 7 to one side, I also have to add it to the other side because I want to keep my equation in balance. On this side, I'm left with x, and on this side, I end up with 1. One of the things that's really important as we get into more difficult work in algebra is that we're checking our work as we go. So even though on something like this it seems a little silly, I really want you to get in the habit of checking your answer. One is the solution that makes this equation true. And so if 1 makes it true, then I should be able to rewrite the exact same equation with 1 instead of x and simplify both sides and have them equal to each other. I like to put a check mark to say that I've checked it. It also makes me happy, so I add a smiley face. You do not have to add the smiley face. The check mark is a great idea, but I'm not going to hassle you about it if you don't do that part. So that's our first example. I'm going to erase my little extra line here. I've got another example coming up. How about if I have h plus 2 pi equals 3 pi. And I'm showing you this example just to illustrate what you would do with pi. Remember, pi is just a number. So it's 3.14. I could multiply this and have 6.28. Some of you would go further and round it in a different place, but it's a number signified by this symbol, this Greek letter pi. But I can just keep it as a number. So I don't have to substitute in 3.14. I don't have to substitute in 22 over 7. This is just a number, and I'm going to follow the steps of my opposite steps. So I'm going to subtract 2 pi from both sides. Notice that I am writing it on both sides of the equation. So that is required. I want to see it on both sides. If you draw a line down the middle, that helps you to remember that you're keeping it in balance. Again, the line to me is optional. It's not optional of whether or not you show this on both sides. So on this side I end up with h, and on this side I end up with 1 pi, or simply pi. And most of the time when we're working with algebraic equations, we can leave it in terms of pi. So I never have to write 3.14 unless it's a word problem, I want an exact number. I can leave it almost always in terms of pi. And then of course I want to remember to check my equations, so I'm going to put that number pi instead of h, plus 2 pi equals 3 pi. This is 3 pi and 3 pi, and it checks. The only thing that's optional in this whole problem is that check mark. Everything else that I am showing here should be included in your work as well. I'm going to do a couple more examples and then I will give you practice problems. Example number 3, we're going to switch over and do some multiplication and division. So the first problem that I'm going to give us is 3x equals negative 27. So the operation is currently multiplication. I know that to solve this problem I want to isolate x, and to do that I want to undo the operations that have been done. So it's currently being multiplied. I want to divide. When I divide, I'm going to just draw that fraction bar, because every division problem is a fraction, and every fraction is a division problem. I'm also going to divide this side by 3, and end up with x equals negative 9. And you might think you're done, but you should, again, always check. So what a solution means is that negative 9 is the value of x for which this equation is true. So I'm going to rewrite the equation and say that if I'm saying that negative 9 makes it true, then this should be a true statement. I'm going to simplify both sides until they're equal, and then I've checked it. For me to say I'm simplifying both sides when our problem is this simple sounds a little crazy, but we will be, by the end of the week, working on much more difficult problems, and so I'm going to use the language that we'll continue to use even when the problems get to be more difficult. I'm going to now do one with a fraction. So let's say I have negative 3/4 n equals negative 2. When I'm multiplying n times some number, I know that I want to divide by that number to get it to equal 1. So right up here, it was 3, the coefficient was 3, so I divided by 3. Here the coefficient is negative 3/4, so I'm going to divide by negative 3/4. I am perfectly fine with you writing divide by negative 3/4 or divide by negative 3/4. But I'm also okay, I'm going to write this again, with you multiplying by the reciprocal. Because I know when I'm working with fractions that to divide by a number is the same as multiplying by its reciprocal. So if you would prefer, you can write negative 3/4 times negative 3/4. Because a negative times a negative is going to be a positive. And 3/4 times, sorry, I've made a goof. This should be its reciprocal. I'm going to erase it in just a minute. Actually, I'll erase it right now. This is the beauty of erasable pens. If you are not using a pencil, please either use a pencil or an erasable pen. Those of you who like to write in pen, the new erasable pens are amazing. I am a lifelong pencil addict. I've always used pencils, and I just recently have switched over to the pens because I just like how they're smooth on the page. So again, I made a mistake when I first wrote this down. I'm going to multiply by the reciprocal. I'm going to divide by the same number. Dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to do that on both sides. On this side I end up with n. On this side I've got a negative times a negative is a positive. 2 times 4/3 is 8/3. Again, I'm not done. I need to double check, so I've got -3/4. I'm saying that n is 8/3, so I'm going to put that in parentheses. That whole thing should equal -2. And I've got a negative times a positive, so that's going to equal a negative, so I'm good on my negatives. Then I'm going to multiply these two fractions, and if you remember, I can cross cancel, so that becomes a 1 and that becomes a 1. That's a 2, and that's a 1, so this is -2 equals -2. I've checked and I'm happy. Now that we've gone through some examples to remind ourselves how to solve one-step equations and to review what I'm expecting from you in terms of showing your work, I'm going to move from examples to practice problems. So I'm actually going on to my next page. So I'm going to give you some practice problems, and then the video is going to pause for you to finish the practice problems and check your work. So here's some practice problems. I'm going to ask you to do these problems and then enter your answer. I will comment that when I wrote these problems down, I used X sometimes and I used another variable another time. I am always okay if you change a variable to X. So say, for example, the variable is C, and you don't like C for whatever reason, or the variable is S, and you get confused because in your writing your S looks like a 5, you can always change that variable to X, which is actually what I did on a couple of these problems. So again, I'm going to ask you to finish these problems and then enter your answers. Now that you have done the work, you've entered your answers so that I can get a feel for how you're doing. And now I'm going to show you the answers, and in your notes you should be checking your work to make sure that you have included everything that you need to include. I would suggest if you missed something, you didn't have something that you needed, that you cross out or that you add in another color, so that you can highlight for yourself the things that you needed to fix about your work. So problem number 1 should be super straightforward. Problem number 2 had a little bit of a wrinkle because this was -W. So I multiplied times 8 because that's often what I see students doing. And then I get to this point and I have -W equals 48. But I don't want to know what -W is. I want to know what W is. So really what is happening from here to here is I'm multiplying times -1 or dividing times -1. I don't have to write that down. But when I multiply this times -1 to get it to be a positive, this also gets multiplied by -1 and that becomes a negative. So basically when I change the sign on the variable, it changes the sign on the other side. So this should be -48. Alternately up here, I could have multiplied times -8 in the first place. So again, I just wanted to clarify that. On my check, I have -W, and so W was -48, so I have minus a negative. This is really like saying multiply -48 times -1. The 1 is kind of invisible there, and that makes a positive 48. I'll let you look at those last two. The last thing we're going to do each day when we finish taking notes is upload our work into our digital portfolio. I'm actually going to make a separate video to show you how to do that. So that's the end of this one.